All right, in the previous video, we were on page 3 of your notes on circles, and we looked at how you had to find the radius if you had the arc length and the central angle. But sometimes you'll get a question like you see in example 4 on page 3. In this one, you're given the arc length and you're given the radius, and you have to find the central angle. So this works much the same way in the ones that we saw before. Remember, your method, consistently you'll see you're doing this throughout the unit, is you take the formula you need and then you plug in the numbers in the spots you know they're supposed to go, and that way you figure out what's missing. So here, let me just write down what the formula is that I'm going to need to know. I know that arc divided by circumference is equal to the central angle, which I'm going to use as x degrees, over 360. Right? So arc over circumference equals x degrees over 360. I'm going to put that up here. And again, put little lines over because it's arc divided by circumference equals central angle divided by 360. If I can set up this proportion, I know I can cross multiply or I can fish method, and I can figure this all out. So again, next step, plug in the numbers in the spots where I know they go. I don't know the central angle, so this is just going to stay x degrees up here. But I know the arc here, and that's going to go up there. You might be saying to yourself, well, the circumference, I don't have the circumference. So I've got the arc, which goes here. I don't have the central angle. I don't have the circumference. What am I supposed to do? Well, remember, whenever you have a radius, you know that you can find the circumference. So let's do that over here. Let's do a little sub-problem over here. And we know that circumference equal to 2 times pi times the radius. So now I can plug in the numbers that I know to figure out the circumference. Circumference equals 2 times pi times radius, and the radius is 26. And by all means, let me plug in 26 as my radius. Now, again, pi might look like a variable to you at first, but it's just a number like any other. So here you're just going to say circumference equal to the calculation I get when I do 2 times pi times 26 in my calculator. Let's do that. 2 times pi times 26 gives me 163.36. Right, so that's my circumference. Circumference is 163.36 centimeters. Okay, now that I've got that, I can move on and figure this out over here. Arc over circumference equals x over 360. Now I do have my arc, which is 32 right up here, and I've got my circumference, which I figured out is 163.36. That gives me everything filled in except for one spot, which is the central angle. So let's plug in the numbers that we know. We know that arc is 32 and that circumference is 163.36. So if arc is 32, still don't know x, still don't know the central angle, I've got 163.36 is my circumference, and I know that I'm going to have x over 360 over there. Let me just make this look a little bit easier to understand. Okay. Arc over circumference equals x over 360. And again, little fraction lines so we know what we're talking about. Okay, once I've got it set up like this, in order to find x, there's really only one step left to do. And it's one that you guys know really well by this point. That's the fish method, right? I take the number that's opposite the one I'm looking for, I multiply it by 32, I divide by 163.36, and that'll give me x. So let's do that operation. First, let me write it out to make sure we all understand what I'm saying. In order to get x, it's going to be 360 times 32 divided by 163.36. Right? That's how the fish method works. I'm just going from this to this. Then we get out our calculator and we do it. Okay? I want to save this number, so I'm going to put it in the memory of my calculator like that. And I say 360 times 32 divided by my circumference. Sorry, by my circumference. And I end up with my central angle, 70.52 degrees. And it's still round to 2 decimal places. So x is 70.52 degrees. Remember, degrees is your unit here. You can't forget that. So your central angle here is 70.52 degrees. All right, let's do another one. Once again here, I can see I'm going to have to figure out the circumference given this radius. Right? I'm going to be using a couple of formulas again. I'm going to be using this one here, arc over circumference equals x over 360. And I'm going to be using this one again. Circumference is equal to 2 times pi times the radius. So in this case here, if I want to get the circumference, I take this radius and I plug it in to that equation. Circumference equals 2 times pi times the radius. Circumference equals, let me do a big C just to not be confusing, 2 times pi times the radius, which is 319 millimeters. Like that. It's going to give us some big messy numbers to deal with. So I get out my calculator. I do 2 times pi times my radius. And I get 2004.34 millimeters. I know it's a 3, but you got to round up because of that 6 there, right? So 2004.34 millimeters is my circumference. And if that's the circumference of the whole circle, then really what this problem is asking me to do is figure out how much of that circle in degrees, how many degrees is 182 of that. Any guesses here? This looks like it's maybe about a little less than 10%, right? 10% of 360 would be 36. Well, it's got to be a little less than that. I'm going to guess is about 30 degrees. Let's see what gives us. All right. So if I plug this circumference in here, and I plug this arc in here, then I can fish method my way out of this little problem here. Again, the arc is 182, and the circumference is 2004.34. Again, let's line this up so we can see what we're doing a little better. All right, I've plugged in everything in the right spot. Arc goes to the arc spot. Circumference goes in the circumference spot. Now I got a fish method, right? And let me just write out what the fish method will ask me to do. It says to get x, I do 360 times 182 divided by 2004.34. So again, x is 360 times 182 divided by 2004.34. I know there's 2 x's in here, which is a little bit confusing, but it's kind of the limitations of the program I'm working on here. Okay, now I go back to my calculator to do this calculation. I want to store this number. You guys in your calculators, you can just use ands. You know that thing here, if you use second down, and I think there's a button down here where there's a little written in blue above it, it says ANS. I'm storing things in the memory, but you guys can just use answer whenever you want to use the number you had kept in here. Okay, so I've got 360 times 182 divided by 2004.34. And that gives me 32.69 degrees. X equals 32.69 degrees. So I was a little off. I think I said 30 degrees. But even if I'm a little off, I see that I'm pretty close. And one of the reasons why I would do an estimate like that before I would actually do the calculations to make sure that if I get the answer at the end, it makes sense. It tells me that, well, I probably didn't divide somewhere where I was supposed to multiply, or I probably didn't multiply by pi twice or anything like that, the kinds of problems that you sometimes run into in these questions. Okay, example 5. Calculate the circumference of a circle, given that an arc of 65.8 centimeters is contained by a central angle of 45 degrees. Make a diagram. Now, I know it says make a diagram here, and I know how most of you would read that as saying, do not make a diagram. I can understand how that happens, but it says make a diagram. So, what do you think you should do? That's right, make a diagram, because it'll make your life a little bit easier. So, this is my fancy diagram of a circle. It looks like this. and I say to myself, okay, I've got a central angle of 45 degrees. So remember what a central angle looks like. That's just an angle going from between two radii, like that. And I say, okay, 45 degrees. It doesn't have to be to scale, but you do want it to look kind of like what you think 45 degrees would look like. Right? This is actually pretty close to 45. 45 degrees would be right in there. So I've got a central angle of 45 degrees, and I've got an arc of 65.8 centimeters. What does that mean again? The arc is this crust of the pizza, right? And I know the length of that arc is 65.8 centimeters. So if I'm asked here, now I've got a diagram that's just saying find the circumference of the circle. Okay, all the work was figuring out what I had to do. Now I just have to find the circumference. You see, actually, this is an easier one to do than the ones we were doing in example 3 in the last video. Because in this one, it's not asking me to find the radius even. It just says, give me the circumference. So, best thing to do, let me figure out what I'm going to use. I'm going to take this formula here. And then I put in the parts that I know. I know the arc is 65.8 centimeters. I know the central angle, which goes here, is 45. And then if I have that all set up, it's going to be real easy to find circumference. Okay. The arc is 65.8 centimeters. The central angle is 45 degrees. And once I have that set up, everything in its proper place, I'll be able to figure out what the circumference is just by using the good old fish method. Okay, let me just write out what the fish method will do. If I want to find this one down here, I start next door to it, 65.8. I do 65.8 times 360 divided by 45 to get my answer. So circumference will be equal to 65.8 times 360 divided by 45. Let's do that calculation real quick. 65.8 times 360 divided by 45 gives us 526.4. So my circumference, which is the answer to the problem, is circumference of this circle, it's a word problem, so I'm writing it out, is, oh, I forgot what the answer was, 526.4, sound about right? Centimeters. And then I'm going to circle that just to make sure Mr. Parr knows that this is what the answer is. Okay, now something that some of you might have noticed with this one is that there's maybe a quicker way of doing this. Because a 45-degree angle, a lot of you guys may have noticed right off the top, well, that's just like half of a 90-degree angle. And a 90-degree angle is just a quarter of a circle, right? 90 is a quarter of 360. In fact, some of you who eat a lot of pizza will notice that very often when you slice up a pizza, depending on the size you get, usually if you get a large pizza, a lot of people happen to get that from the pizzeria, and it's already cut up into 8 slices, and each of those is 45 degrees. So again, a quarter would be 90 degrees, so 45 is just chopped up into another extra piece. So you got 8 slices of pizza would be 45 degrees. So if you know that the arc is 65.8, and you want to find the whole circumference, all the crust of the pizza, you just have to take this number and multiply it by 8. That's really what you're doing here. I'll show you. If you just take 65.8 and you multiply that by 8, you'll get exactly the same number as before, 526.4. Okay. Now, in this case, using this formula doesn't take you wrong at all, but it's just something else to notice about what's going on here, the way that this formula is working.